It's called dark because it doesn't interact with any light, any radiation. That's why it's called dark. It's called matter because it acts like matter because it pulls using gravitation. It's distributed everywhere. It's passing through us right now, but nobody has detected that particle that has very weak interaction. As dark matter comes and hits your nucleus, it's going to leave very little amount of energy. Okay, so just like a fly hitting the car. So the question is, how do you know? You could actually design a car where you can be sensitive to a fly hitting your car. Okay, you just have to have the right sensor.
The detectors that we are using are large detectors. In our environment, there are all these cell phones, wires, electromagnetic interference, and so on. So you need to shield against them. So your instrumentation is not sensitive to noise, to environmental noise.
And so what we do is we put these things down in a mine shaft, let the earth automatically shield all of the other things, and then wait for the dark matter particle to hit it. When it hits it, it creates a small change in heat. And so we measure that by superconductors, and it creates a small amount of charge. And we measure that by very sensitive electronics. And looking at the two and comparing them allows us to say whether or not it was some standard particle in the universe that we already know fairly well, or a particle that is new, that is different, that doesn't happen very often, but is massive, has a lot of mass associated with it.
Usually when you plan these experiments, they become very expensive. Why? Because you would be finding a reactor at some place, find detector from somebody, come up with electronics from somebody. But here we have all the expertise we need under one roof.
We had this opportunity to work to close the loop basically here. We fabricate the detector, we process detectors here, and we can test them in the refrigerator at the same time, which gives us a big leverage in terms of research. So Texas A&M provided that environment. We are looking for a very big question and very challenging experiment, so it is worth to spend some dollars on that.